Gabil is a cuaig proper hain ceiste sé. Donna is arranging a loan and is examining two different repayment options. Part 1. Bank A will charge him a monthly interest rate of 0.35%. Find correct to three significant figures the annual percentage rate, APR, that is equivalent to a monthly interest rate of 0.35%. Some of the important things to underline here: we have to give our answer to three significant figures, the rate that we're starting off with. We want to find the annual equivalent rate. So write in then the key information. We know the monthly rate, or is 0.35. As a decimal, we have 0.0035. We need to find I. So we know that 1 plus or to the power of 12 is equal to 1 plus I. Or it's the monthly rate and I is the annual rate or the yearly rate. We need to learn that off by heart. We won't get that in the log tables. So now I substitute in what I have for or and solve for I. So 1 plus 0.0035 to the power of 12 is equal to 1 plus I. So using my calculator, I find that this will give me 1.0428180007. When I subtract 1 from both sides, I'll be left with 0.0428180007 is equal to I. So they told us to round it to three significant figures. The first three significant figures are 4, 2, and 8. In order to change it from a decimal into a percentage, I multiply it by 100 anyway. So multiplying it by 100, we're going to get 4.2818007. So then to three significant figures, we have 4.28%. Part 2. Bank B will charge him a rate that is equivalent to an APR of 4.5%. Find correct to three significant figures the monthly interest rate that is equivalent to an APR of 4.5. So in this case, we're told that I is equal to 4.5%, which as a decimal is 0.045. And we need to calculate the monthly rate, so we need to calculate or. So using the same kind of formula as we used before, 1 plus or to the power of 12 is equal to 1 plus I. We fill in what we have for I to solve for or. So 1 plus or to the power of 12 is equal to 1 plus 0.045. So 1 plus or is going to be equal to the 12th root of 1.045. Or, just to note, we could write this as 1.045 to the power of 1 over 12 as well. So using our calculator, we get 1.003674809. So again, we're asked to give it to three significant figures. Or first of all, when we subtract 1 from both sides, it's going to be 0.003674809. So changing this into a percentage, we multiply it by 100. So we're going to get 0.3674809. And then to three significant figures, this is going to be 0.367%. Part B. Donna borrowed €80,000 at a monthly interest rate of 0.35%, fixed for the term of the loan from Bank A. The loan is to be repaid in equal monthly repayments over 10 years. The first repayment is due 1 month after the loan is issued. Calculate correct to the nearest euro the amount of each monthly repayment. So the first thing we're going to do is look in the log tables for the formula that we need for repayments of loans. So if we look at page 31, we have a formula. A is equal to P multiplied by I by 1 plus I to the power of T over 1 plus I to the power of T minus 1. So this is when A is the repayment amount and P is the principal amount. So in the log tables, it says that it's the annual repayment amount, but if we're using months for time, then it will give us the repayment amount for the month. So we're looking for A, and we know that P is equal to 80,000. So before we put everything into the formula, we're just going to identify what we're actually using. So as I said, A we're looking for, P is 80,000, I is equal to our monthly rate as a decimal, so 0.0035, getting that from here, and T is our time in months. So if we want the monthly repayment amount, we need to use our time in months as well. So 10 years, so we have 120 months. So just watching out for other things like we have to leave our answer correct to the nearest euro. So now that we've identified all the variables that we need to fill into the formula, we can go ahead and fill them in. So we have 80,000 multiplied by I, which is 0.0035 by 1 plus I to the power of 120. That's 1 plus 0.0035 power of 120 minus 1. So when we simplify that, we're going to get 80,000 multiplied by 0.00532296 on the top and 0.520846 on the bottom, which is going to give us 817.59. So our answer, including our units correct to the nearest euro, is 818.